pre-algebra. We are kicking off the school year 2023-2024 with CO1, identifying whole numbers, integers, and rational numbers. So some definitions that you may or may not be familiar with. And so usually when we start a lesson, we will start with kind of the terms that we'll be using in the lesson, right? It's important to know, for you to know what I mean when I say something like whole number, integer, or rational number. So if you remember this from last year, perhaps you talked about it. What is a whole number? You know, like science, where like our animal kingdom is separated into different categories, right? Our number system is kind of the same. James, I saw your hand up first.
It's like it doesn't have any decimals or like negatives.
Okay, so it's a positive non-decimal number. Positive non-decimal number. Such as 1, 2, 3, 4, 5, 6, 7, right? When you first learned how to count, you were counting using the whole numbers. And that word whole, you know, if it's not a whole, that is like 2.5, right? It's 2 wholes and half of a third whole. The very fact that it says whole kind of leads to that non-decimal piece, okay? There's no parts to them. They are simply whole numbers. How about integers? What would an integer be? James?
A negative.
Can it be a decimal?
Yes.
No. Okay. Integers are actually all the whole numbers, so they can be positive. They can also be negative, non-decimal numbers. Okay. Positive or negative non-decimal numbers. So when you see a typical number line, right, you just kind of see it looks like this. It's got 0 in the middle and 1, 2, 3, right? -3, -2, -1, 1, 2, 3. Those are all integers. Okay? They're positive or negative non-decimal numbers. So a number like 7 is whole, right? It's also an integer. A number can belong to more than one category if it fits that definition. How about rational? Rational number. Can rational numbers be positive? Yes. Can they be negative? Yes. Can they be fractions? Yes. Can they be decimals? Yes. Rational numbers contain a lot of different types. Rational numbers can be positive or negative fractions or decimals, but there's a caveat to this, that end or repeat. Okay? Positive or negative fractions or decimals that end or repeat. Yeah.
Well, could you give an example of that end or repeat?
Sure. So a decimal that ends would be like 3.14. Right? A decimal stops. A decimal ends. Okay? Which you've seen 3.114 used as what? An abbreviation for pi. But the actual value of pi, the reason why we use 3.14 is because the actual value of pi goes on forever. Right? I've got the first 100 digits here, but they've got computers that have calculated to billions of places, and it still does not end. There's still no pattern. It doesn't repeat. Okay? So pi would actually be an example of an irrational number because it doesn't end. It doesn't repeat, which is why we use the abbreviated or rounded decimal 3.14. But this itself is rational because it ends. Okay? A number like 3/5 as a fraction, that is a rational number. Right? This is a pretty big set. There's a lot of numbers that can fit in that rational number set. But if it's not rational, the opposite of rational is irrational, right? Pi is an example, okay? The definition of an irrational number is a decimal that does not end or repeat. Goes on forever. Okay? So we've talked about examples of decimals that do or don't end. What about that repetition? Matthew asked for an example of that repetition there. How do you show if a decimal does repeat or doesn't repeat? Anyone know either side of that coin? Okay. If a decimal repeats, I'll do it in red so it kind of stands out a little bit here. But if it's like 0.19191919 forever and ever, we have the 0.19, and then there's a little bar that goes over the part that repeats. So you'd see that, and you'd see, oh, that means it's 0.1919119 for ever and ever. Okay, that means it repeats. If the decimal doesn't repeat, it'd be something like 4.1682506 ... Right? You ever get a text from your parents and they're like, you on your way home yet? And you respond like, no, ... Like, I'm not, but there's probably more to the story here, right? Maybe I should be on my way home. It means that there's more. It's just, there's no repetition. There's no pattern. Okay, so we just kind of cut it off there. So if you ever see someone with a ... that means it goes on. It doesn't repeat. It's an irrational number. Versus the bar, and that means it does. Okay? Questions, comments, concerns, complaints, compliments, congratulations, criticisms so far? No? All right, very well. So if you're more of a visual person here, and first of all, has everyone got these definitions? I would have to clear it and scroll down. Anyone still right now? No? Okay. So if you're more of a visual person here, this chart, right, can kind of help you, hopefully. Okay. The rational numbers are a big set. Within the rational numbers, we have the integers, and within the integers, we have the wholes. So give an example of a whole number. James. 2. 2 goes in the whole number box. 2 is also part of the integer box. Is 2 also an integer? Yeah. 2 is also part of the rational number box. Is 2 also rational? Yeah. Okay. Give an example of an integer. 5 is an integer. Give me an example. I should have been more specific of a negative integer. -5. I can't put -5 in the whole number box because it's not. So -5 would have to go in the integer section, right? It's not whole. Okay. 5 could go in the whole number box because it is whole. It's also an integer. It's also rational. But if I'm talking about a negative number here, I can't put it in the more specific category because it's not whole. I've got to start with the integers. Is -5 rational? Yes. That's why it's part of the rational box as well. Okay? Give me a number that is rational but not a whole or not an integer. Basically, give me a decimal or a fraction.
2/5.
2/5. Can I put 2/5 in the whole box? No, it's not whole. Can I put it in the integer box? No, it's not an integer. I have to put it in the rational. Okay, I have to go all the way out to the outermost layer, right? Because it does not apply, it doesn't fit the definition of a whole number or an integer. Lucy.
So I have a question.
Yeah.
If you had the number 2, for example, you would just put it on the whole number box?
So I think your homework says to label all categories that it applies to. Okay. The most specific category that 2 belongs to is whole. but on your homework you would also label it an integer and a rational number. Okay, but any number that's whole is also an integer and also rational. Any number that's an integer is also rational, but there are values that are just rational. Okay? And then those irrational numbers that aren't part of this at all would be like pi, right? Negative 6.1428 ... right? Things that aren't a part of either. Yet another way to think about it. You are a 7th grade student who is also a part of the middle school, right? Are 8th graders 7th graders? No. But are 8th graders part of the middle school? Yes. Right? Are integers wholes? No. Are wholes integers? Yes. Okay? And all of you are a part of SVDP, which are rational numbers. If we were talking about a 1st grader, I can't put a 1st grader in the 7th grade category. I can't put a 1st grader in the middle school category. I have to put a 1st grader in the most broad set, St. Vincent. However, all of you are a part of all three. 7th grade, yes. Part of the middle school, yes. Part of St. Vincent, yes. Same kind of thing. We're starting very specific with the positive non-decimals and then just branching out. Okay? And then someone who goes to a totally different school altogether, not a part of St. Vincent, not a part of any of this community, is just irrational. Hold on. Wait. I had a crowd laugh at one point when no one laughed at my jokes. I can't find it. Oh, well. Okay. Question so far? Hey, if you recall this symbol from last year, it means that these are common mistakes that folks tend to make because either they're working too quickly or it's just kind of a quirky thing. When you see something like 42/7, your reaction might be, oh, fraction, rational, which it is, but what is 42 divided by 7? 6. Uh-oh. 6 is also what? Whole. It's also what? Integer. Okay? So it's the easy way to say, you think when I see a fraction, I know it's rational, which is true, but you have to think, can this simplify? Is this also a whole number? Is it also an integer? Okay. All right. So let's do some examples together here. It says classify each number, and typically the Mr. Happy Pencil section, that's your homework. So we'll do some example questions from each section to kind of know what to do when you start. And then again, just a reminder, tomorrow I'm not going to grade your homework on accuracy. It's going to be graded on completion, right? If you get a question wrong, when we go over it, you're responsible for fixing it, but I want to see that you gave it the best effort. I think of homework as like practice for a sport or practice for the play some of you are in. Are you going to get penalized for messing up your lines when you're practicing? No, that's why you do it. That's why you practice, to make mistakes and then learn. Okay, so homework is the same. This is preparation for the test, and so all I ask is that you give it your best effort. If work needs to be shown, show your work, do all the things, but then mistakes are okay. 65. What category? It does say list all applicable categories. What categories does 65 belong to? Bennett.
Whole number, integer, rational number.
Good. It's all of them. Whole, integer, rational. Okay. If you want to abbreviate WIR, you can. Okay. Negative 12.7. Zeke?
I have a question about the first one.
Yeah.
What is being a rational number?
So the abbreviation for integer is I. If it was irrational, it would be IR.
Oh.
Okay, yeah. Do I have that up at the top? definitions, yeah, an integer I and then IR, yeah. Okay. Thank you though for asking. I'm sure you weren't the only one wondering. Aiden,
A rational number?
sorry? Irrational or rational?
Rational.
Rational. Rational only?
No.
What else is it?
Irrational?
Why?
Oh, never mind. It's not.
Enzo?
It's a negative, so it's an integer.
Well, look at that definition for integer. It's a positive or negative non-decimal, right? Whereas negative 12.7 does contain a decimal, therefore it's not an integer, it is not whole. However, it is rational. And to Aiden's point earlier, nothing can be both irrational and rational at the same time. Okay? It's either rational, maybe some other stuff there, or irrational. You'll never have something that is both. Right? Give me another one. That looks maybe particularly interesting, challenging. Aiden.
What is the line above 2.78?
Good question. What does this little line mean here above the 7-8? What does that mean? Yeah, Isabel.
The 7 and 8 keep on repeating.
The 7-8 repeat forever, right? 2.78 forever, right? So technically the decimal doesn't end, but because it does repeat, that does make it rational, and we can show that by putting that little bar over the 7-8.
Wait, it's not irrational, it's just rational.
It is rational.
But it goes on. Yeah.
But if you look at the definition for rational, what we said was a decimal that ends or repeats. Okay, an irrational number goes on forever, has no pattern, doesn't repeat, it just goes and goes and goes and goes and goes. So if the decimal does repeat, it is rational.
So the line over the 78 means it repeats?
Yes.
Okay.
The line over the 7-8 means that repeats, and any decimal that repeats is rational. Is rational. Okay? Kind of get the gist of what's going on here, James?
Wait, what would be the one for 2.35?
1.24, where do you see that?
No, 2.35.
2.3. Oh, so that little line.
2.35.
Right. So this one, only the 5 repeats, not the 3. So if we were to write this out, 2.35555555 forever, okay, it doesn't end, but it does have that repetition, therefore it is rational. Therefore it is rational. Good. Jillian.
That's what I was going to ask.
Excellent. Great minds think alike. Okay, good? All right, page 2. Scroll on down. It says answer each question. Some questions may be not possible. What is a rational number that is not an integer? Give me an example of a rational number that is not an integer. Aiden? Okay. James?
The 2.78 with the line across.
Okay. 2.78, showing that 7-8 repeats, that is rational because the decimal does repeat. However, it's not an integer because it's a decimal, right? So if you think about that chart that we had earlier, where you had the rational, the integers, and then the wholes, okay, this one would have to be way out in here because it is rational, but it's not part of that integer section. Because it is a decimal, it is not an integer. Okay. The next one, what is a whole number that is not rational? What's a number that we could put in this section here for the wholes, but would not be a part of the rational set?
It's impossible.
It's not possible, exactly, right? Every whole number must also be rational, okay? Because the whole number is part of the rational set, the whole thing, okay? So that would be example one that's not possible. All right? And then the bottom section says determine whether the statement is always, sometimes, or never true. An integer is a whole number, always, sometimes, or never. An integer is a whole number. Sometimes. What's the condition that an integer would also be whole? Matthew?
A
5. If the number is positive, right? A positive integer is also whole. What's a situation where an integer would not be whole? Nolan? Did I hand up?
No.
Oh, okay. James?
Like -5.
If it's negative, okay? So positive integers are also whole. Negative integers are not whole. That's the difference between a whole number and an integer, right? Positive versus negative, okay? And then use a calculator to evaluate each radical and classify it as rational or irrational. Someone who's got a calculator, or if you just know your perfect square is super well, what is the square root of 225? And remember that the definition of a square root is what number times itself equals 225.
And you just do the thingy.
Yeah, the square root button is above your x squared key. So it's like you have to press the second function first and then press the x squared key to give you the root. But what number times itself is 225, eh? Nope, not 23, less than that. 15, okay? So the root of 225 equals 15. Is that rational or irrational? 15 is rational. Why? Because it ends, right? 15. It's a whole, it's an integer, it's also rational. Something like the root of 83, what do you get for the root of 83? A decimal. Is it pretty? So who's got the root of 83 in there? Right there.
What button is it again?
So press the second function button way up in the top. It's like your shift key for the calculator. And then the x squared button, it's near the 7. Okay. So if you've never used a root key before, if you want to take the root of 83, here's the order that you will push buttons in your calculator. First, you're going to push the second function button, which is the very top left one. It's usually a different color from all of the other ones. It's like yellow or green or something like that. But you need to press that because just like on a computer, when you want the $sign, you have to press the shift key first and then the 4, right? The root symbol is not on an actual button. It's above the x squared key, right? So on a computer, if you were to like compare this, you know how the 4 keys got the $sign on it? If you want that $sign, you have to press shift first. Same thing here. If you want the root symbol, you have to press that second function button first. So you do this, and now in your calculator, it's going to give you this. The root symbol and then a parenthesis. Okay? Who's having trouble getting this far here? Okay.
I don't have that. I have an X.
So here's the second button, right? And then here's your x squared key.
Oh.
No, press the x squared key. It'll give you the root. Matthew, you got to figure it out? So press the second first, and then press the x squared button, and that'll give you the root there. Yes. Anybody else need some assistance? Yes. Good. Yes, that is. So that's the correct. That's what we'll talk about. That's what it is. Okay, so you did 83 squared. You first press the second function button, then the x squared key to get the root. You see that root symbol is not actually on the button. So second first, then the x squared key. Now type in 83. Yeah.
Isn't it rational?
Well, we'll get there in a second. You got a different calculator. Okay, do you know how to use it?
Yeah.
Perfect. Yeah, so keep that answer. We'll talk about that in a minute.
Second,
Yeah, good.
10.
So the second function first,
Thank you.
and then the x squared. And that'll be the rest. Got it? Got it? Yeah? Got it? Harrison? So press the second function button first. Yep, and then 83 goes in there. And then press the x squared.
And then what?
Simple. Good. And then 83. Aiden, you good? Yeah. Jillian, got it? Everyone here? Okay, now type 83. Those that just came back with their calculators, Schaefer? Got it? Okay. So, if you find the root of 83, what do you get? 9.1043.
3.579.
You're doing the whole thing.
Okay. Now, your calculator, the only reason why this decimal ends in your calculator is because your calculator runs out of space. Okay? It can't give you any more numbers because there aren't any other spots. Right? This is considered a non-perfect square. Have you heard that term before? Perfect squares versus non-perfect squares? Okay? 225 is a perfect square because a whole number, 15, can multiply times itself to equal it. Something like this, if you ever get a decimal from a square root, it is always going to be an irrational number because this decimal does not end. Your calculator is limited. It's a tool. It can only do so much, right? It appears like it ends, but that's only because it runs out of spaces. It's an irrational number. So if you take the, let's practice this again here. Take the root of 200. Press that second function key. Press that x squared key. Get the root. The root of 200. Does something times itself? Does a whole number times itself equal 200?
No.
No. What's the decimal?
14.142135.
Something nasty, right? If it's a nasty decimal, then it is going to be an irrational number. Okay? 200 is not a perfect square. Something times itself does not equal 200. Now, if you're thinking in your head, well, what about 100? 100 plus 100, right? 100 plus 100 equals 200, but it's not something times itself. Okay? So it's an irrational number. Then the last question, this is the brain buster question. This is the question that kids like to come in with their homework and they have it blank and they say, I didn't get it. Okay, well, it's supposed to be a brain buster question. I want to see, I want to see the struggle with this. I want to see either the work that you put into it, or if there's no work on your page, I better see tears. Sweat beads that dropped on your paper from trying and thinking so hard. Don't just leave it blank. Don't give me the IDK. Okay? I don't count that. Show me what you tried, or if you really don't get it, why don't you get it? What's your question? But don't just leave it blank. The question says, you and your parents are gathered around the TV one night watching Discovery Channel when suddenly you lose your satellite signal. Not being used to interacting socially, things are a bit awkward. Then you get an idea for a game. Each of you will take turns saying a number from one of the categories listed above. Okay? One of you only say rationals. Your mom only says integers. Dad only says whole numbers. And the game is, the winner is the person who can say numbers from their category the longest. Right? Assuming you are each familiar with the categories, who will win and why? Okay? So if the three of us are playing this game here, Amelia, you can only say wholes. Matthew, you can only say integers. I can only say rationals. Let's start to play. What's a whole? 3. Integer.
2.
Right? 10.58. Whole number. Integer.
5 point.
Or integer or not.
5,
decimals.
yeah.
Negative 14/5. Whole number, integer, rational. Whole number, integer, rational. And the winner is the loser is who runs out of numbers first, right? The winner is whoever can say numbers from their category the longest. Who's got the biggest category, okay, is the winner. And then defend your answer. Okay? Questions on the homework. The homework is to finish all of CO1. You have a bell ringer on it tomorrow. If everybody comes back with their homework complete tomorrow, then we will play the number game, which is a whole nother level of fun, and you can win donuts or cookies or brownies, whatever you decide on as a class. But you can only play if you all participate in the homework, right? By completing it. Okay? So don't let your class down tomorrow. Get the homework done. Questions, comments, concerns, complaints, Collins, congratulations, or criticisms? Thank you. Yes? All right, you ready for the outro? Yeah. Okay. The outro is I say that's how you math. You say don't forget to like and subscribe. With gusto, too. We really got to sell it, okay? So let's do a practice run. That's how you math. That's how you math. Don't forget to like and subscribe. Let's do it for realsies now. Okay. That's how you math.
Don't forget to like and subscribe.
And hit the little bell.
Hold on. Where's my end button?
No, that's not.
Where's my end button? How do I stop this thing? Oh, there it is.